Hello, everyone, again. That was really weird. Let me try that one more time. Hello, everyone. So we're going to be looking at our second example now, dealing with related rates. And this one's a little bit more trickier than the first one that I showed you, but it's still very doable, okay? You just got to be organized and you've got to make sure that you label everything. So here we have the height of a cylinder that is changing. So the first thing I want to do is I want to draw myself a picture of what's going on. So I'm going to do my best attempt here at drawing a cylinder. So there's my cylinder. And let's see what it says. It says the height of that cylinder. So the height of the cylinder is this, and we're going to call that h. So we're told that dh with respect to t is decreasing at a rate of 4 feet per second. So that's going to be -4. And it says the volume is decreasing. So dv with respect to t, so remember everything's happening with respect to time, is decreasing at a rate of 1,180 cubic feet per second. So again, as the height decreases, so does the volume. Now, what we want to figure out is when the radius of the cylinder is 7, and by the way, this part right there, that's the radius. So I'm going to go ahead and set that equal to 7. So when the radius is 7 and the volume is 348 cubic feet, we want to figure out, well, what is the rate of change of the radius? So basically we're being asked to figure out what is dr with respect to t. So dr dt. All right, so we've got all our information written down. Now what we need is we need an equation that brings all of this together. And the equation that brings all of this together is the volume of a cylinder. And we know from the given question that the volume of a cylinder is pi r squared multiplied by h. Okay, so because we're dealing with related rates, we want to go ahead and take the derivative of this implicitly. Now we have to be careful here because we have a constant of pi, and we also have two variables that we're multiplying together. So we need to make sure that we use the product rule. So whenever you have a constant at the front, you can just take that out. So if I'm figuring out dv dt, I can have my constant of pi on the outside. And then all I need to do is just look at these two variables as products and use the product rule. So let's do that. So the derivative of r squared would be 2r, but remember we're dealing with implicit differentiation here, so I need a dr dt. And then I know that that gets multiplied by h. And then I leave the r squared as it is, and now I take the derivative of h. So the derivative of h is 1, so that doesn't change anything. And then don't forget, I have to do my dh dt because I'm dealing with implicit differentiation. Everything is being differentiated with respect to t. So when I get to this point, remember, I'm trying to figure out what dr dt is. So there's my dr dt. So I have some unknowns that I want to plug in. I need to plug in dv dt. Well, I know what that is from up here. I need to plug in r. Well, I know what that is from here. And I also need to plug in h. Well, that's a problem because I don't know what h is. However, I can find that out because I know that r is 7 when the volume is 348. And because I know that this is my formula for the volume, I can plug these two values in to come up with the height. So let's just do that as a little aside to find h. So here we go. I know the volume is equal to pi r squared times the height. I know everything is happening at 348 for the volume, and that's going to equal pi multiplied by the radius squared. So again, I know the radius is 7, but I don't know what the height is. So now I have this. I've got 348 equals, now 7 squared is 49, so that would be 49 pi multiplied by h. And if I divide both sides by 49 pi, I will get h to be equal to 348 all over 49 pi. Now, you might be tempted to write this as a decimal, and I wouldn't want to blame you for that. However, you need to try and be as precise as you can. The only time that you should ever be rounding is when you get to your final answer. So I'm going to leave this in its fractional form. All right, let's go ahead and plug everything in. So dv dt, I know that to be negative 1180 equals, I got my pi right there. My 2r, so I know r is 7. dr dt, well, that's what I'm trying to figure out. So I'm going to go ahead and write that in red, just so that it's obvious that that's what I'm trying to figure out. And then I need to multiply that by the height. Now remember, this is the height, so it's going to start to look a little messy. So I'm going to try and do my best here not to make it look too confusing. So we've got 348 over 49 pi. So remember, that's the height. And then I'm going to add, now I don't want to smush this together, so I should probably, draw a line down like that to separate it, plus r squared, so that's going to be 49, and then I'm multiplying that by dh dt, which I'm told in the problem was negative 4. And then I'm going to close up my brackets. Okay, so I gave myself enough space there. So now you have to solve this equation. All right, so here we go. Negative 1180 equals pi. So 2 times 7, that's 14. So that's going to be 14 dr dt. And I'm going to be multiplying that by 348 over 49 pi. Minus, because I got 49 multiplied by negative 4, so let's use my calculator for this. So 49 multiplied by 4, that gives me 196. So I'm going to be minusing 196. Okay, so now I just want to go ahead and finish solving this. Hopefully I won't run out of room. First thing I'm going to do is I'm just going to multiply out the pi here. So I've got negative 1180 equals, now if I multiply the pi out to this first one, that pi and that pi there will disappear. So really, I'm only going to be writing the pi onto this 196. Now, I'm also wanting to multiply the 14 by the 348. So 14 multiplied by 348 will give me that, and then divided by 49 will give me that. Now, that's a decimal. Don't really want that to be a decimal. So what I can do is if I do math, frac, enter, it'll reduce that fraction for me. So that's 696 over 7. All right, so here we go. So remember, the pi is cancelled out. I multiplied across. So I'm going to have 696 over 7. Remember, multiply by dr dt. And then also distribute the pi to there. So that'll be minus 196 pi. All right, so it's looking a little bit better now. So now I'm going to go ahead. Remember, I'm trying to solve it for dr dt. So I'm going to go ahead and add 196 pi to both sides. So that'll be 196 pi plus minus 1180 equals 696 over 7 multiplied by dr dt. So here's where I pretty much can start to simplify things a little bit. So let me show you how I'm going to do that. So I'm going to take my 196, I'm going to multiply that by pi, and then I'm going to minus 1180. And then I want to be dividing by 696 over 7, which is the same as multiplying by 7 and then dividing by 696. And if I do all that, I'll get dr over dt is about negative 5 point, and it wants it to 3 decimal places. So 6, 7, and because the number after the 4 is a 9, I have to make that 5. Okay. Don't forget to use whatever units of measurement you're working with here. So radius is going to be feet in this case. So it's going to be negative 5.5, sorry, negative 5.675 feet every second. So basically the radius will be decreasing as well. And that makes sense because if the height and the volume are decreasing, then the radius must be doing so as well. So as you can see, this one's a little bit lengthier. It's not difficult per se, but you do have to really organize your work, label everything, and try not to rush anything. All right, hope this helps. Let me know if you have any questions.